Alright guys, this is part 3 of our lesson on solving and graphing polynomial inequalities. Alright, so let's pick up with number 5. Our first step will be to get 0 on the right hand side. So I'm going to add 7x to both sides. Inequality that we're going to work with for the rest of the problem. Alright, let's try to factor it. Let's see if it factors. Okay, so if I'm going to try to factor this, okay, then I'm looking at the 6 and I'm thinking maybe this is going to be 2 times 3, or maybe it's 1 times 6. Alright? So I will start with 2x times 3x. Looking at the 3, 3 can only be 1 times 3. I won't put the 3 here because that would make a common factor. So I will do 3 times 1 and see how we do. Now we know that inner plus outer equals middle. So inner, I have 9x. Alright, outer, I have 2x. I'm trying to get a middle of positive 7. I can get positive 7 out of this if I do a positive 9x and a negative 2x. So if I make this positive, I'll get my positive 9 middle. If I make this negative, that will make my negative 2x. Also, this gives me the negative 3 because positive 3 times negative 1 is negative 3. So great, we did factor this correctly. Alright, now that we have it factored, we want to find the zeros of the function. So we will do that by setting these factors equal to 0. So if I do 2x plus 3 equals 0 and 3x minus 1 equals 0, this will give me the zeros of the function. Alright, so subtracting 3 from both sides, and here adding 1 to both sides, gives me 2x equals negative 3, and 3x equals 1. Okay, now dividing by 2 and dividing by 3 on both sides, this is going to give me x equals negative 3 over 2. Okay, so that's one of my zeros. And this is going to give me x equals 1/3. Okay? So this this function is degree 2. So it only has 2 zeros, and here they are. Let's see, should we use the, I'm just going to do this by the graphical method because it's just so easy to do the graphical method. Then why not do it? Okay, so using the graphical method, I need to make a small graph here in my work area first. So here's 0 right in the middle, and so over here on the left I will have negative 3 over 2, and then over here I'm going to have 1/3. Okay, no. So these are my zeros. So here at these values the function will equal 0. Now we need to draw a graph of the function. It's quadratic, so I know it's going to be some type of a parabola. The leading coefficient is positive, so that tells me that it's going to be an upward facing parabola. And so I'm going to draw an upward facing parabola through these zeros. Okay, so that would be something like this. Okay. Now, we want to know where the function is greater than or equal to 0. So when we say greater than or equal to 0, graphically we're talking about above 0. All right? In other words, above or on the x-axis. Okay? So because we're accepting values that are equal to 0, let's start by coloring in the zeros themselves. They will be included in the solution set. So that's where we are equal to 0. And so now for the part that's greater than 0 will be the part that's above. Okay, like this. And this is a part that's above. Okay. So these two green arrows represent the solutions. Okay? But we only want the x value, so I'm going to copy this over on the answer side. Just only, whoops, that's not what I wanted. Just only doing the x values. Okay, so I'm going to make a very similar graph over here. Okay, so there's 0, there's 1/3, and here is -3/2. Because it's greater than or equal to 0, I'm going to use closed circles for the boundary points. Okay, because that's where it's equal to 0, and we get to include that. Now, looking at the graph of the sketch of our parabola, we will find solutions starting at -3/2 and then going to the left. So we started here at -3/2, and then going to the left, we will have solutions. All right, and then we have more solutions starting at 1/3 and then going to the right. So here we are starting at 1/3 and going to the right. Okay, so this is the graph of the solution set. Now the solution we need to write in interval notation. So this is -infinity to -3/2. So we will do -infinity to -3/2. And we'll use a square bracket to show that we're including the endpoint. And then we'll go union, and then this one goes from 1/3 to +infinity. So square bracket 1/3 to infinity. Okay, so this is the answer to problem number 5. Okay, that's problem number 5. Okay, let's go ahead and do problem number 6. Alright, since we did the last one using the graphical method, I might do this one using test values, just to mix things up. Alright, but in any case, we're going to start by getting 0 on one side. So let's subtract 2x from both sides. Okay, these are like terms. So that's going to give me 2x squared. Alright, positive x, negative 2x, that's negative x, alright, is less than 5. And now I'm going to subtract 5 from both sides. So that's going to give me 2x squared minus x minus 5 is less than 0. Okay, so this is the version of the inequality that we're going to use for the rest of the problem. Alright, and this is a 0, not like a 6. Okay, let's try to factor it. Let's see what happens. Okay, if we try to factor this thing, 2x squared can only factor as 2x and x. Alright, 5 can only be 1 times 5. Okay, this is not going to work. Inner, outer, middle, don't you know? So inner I have 1x, outer I have 10x. I'm trying to get -1, so that's not working. I'll try it the other way, but this is not going to work either. Alright, I'll try the 5 here and the 1 here. Doing it this way, inner I have 5x, and outer I have 2x. There's no way I can get a -1 out of that either. So I've tried every possible way, and so it's unfactorable. Okay, that means, since it's unfactorable, there are not going to be rational zeros. Okay, so we're going to have some decimals. That's what's about to happen. Now what we could do is use the quadratic formula. So let's do that. Since it's unfactorable, we're just going to go ahead and set this thing equal to 0 and use the quadratic formula. Alright, so setting this equal to 0, we know that A is 2, B is -1, okay, I'm talking about the coefficients, and C is -5. Okay, that's my A, B, and C that we need for the quadratic formula. Okay, alright, please remember this is the quadratic formula. Opposite of B plus or minus square root B squared minus 4AC all over 2A. Alright, let's start with the discriminant, which is the part underneath the radical here. Let's do that first. B squared minus 4AC. Okay, so if I do that first, B squared minus 4AC. B is -1, so that becomes -1 squared minus 4 times 2 times -5. This is called the discriminant. Notice my use of parentheses. You have to use parentheses if you're going to put this in a calculator. All right, you should be able to do it, mentally. But if you can't, then you've got to use parentheses. Okay, so I'm getting a discriminant of 41. Okay, so this is so my discriminant is 41. Once you have that, we can go ahead with the rest of the quadratic formula. Okay, which says opposite of B. Okay, so that's going to be since B is -1, the opposite of B is +1. Alright, then we have plus or minus square root. Alright, and then it's under the square root we have B squared minus 4AC. But that's what we just calculated, so that's 41. And then it's all over 2A. So A is 2, so 2A is 4. So I've got this. Now 41 is a prime number, so we can't simplify this anymore. But what we can do is turn this into a decimal. Okay, actually 2 decimals. Alright, so let's put this in the calculator, but let's do it once with a plus, alright, because the 1 plus radical 41, and then we'll do it once with a minus. Okay? So let's see, 1 plus radical 41 over 4. So that's going to look like this. Go into fraction mode right away. So 1 plus radical 41 over 4. Okay? At first they just give us the same thing over again, but hit the toggle key to force the decimal. Okay, let's go ahead and do 2 decimal places, so let's say 1.85. That's not what I need. Okay, so using the positive version, I have 1.85. 1.85. Okay, so that's one of my zeros. Now let's do it again using the negative version. All right, so, okay, I don't want this, I want this. So the negative version, so now I'm doing 1 minus radical 41 over 4. Okay, so fraction mode, 1 minus radical 41 over 4. Okay, and again, hit the toggle key to force the decimal, and I have negative 1.35. All right, negative 1.35. All right, so these are my two zeros. Okay, so like I said, this time I'm going to try using the test value method instead of the graphical method. Okay, so for the test value method, we can just go ahead and get over into the answer area and start to draw our graph. Okay, so keep in mind the zero. So I have a -1 and a +1. Okay, so I'll have 0 somewhere in the middle. So I have negative 1.35, so I'll put that over here. Okay, negative 1.35. And then I have a positive 1.85. Okay, I'm going to graph these using open circles because we just want the part of the function that's less than 0. So we don't want to include the equal to 0 part, and that's what these zeros represent, equal to 0. So we will leave these out by making them open circles. Okay, now these zeros divide the number line into 3 zones. All right, we have the yellow zone right there, and we have the blue zone in the middle, and we have a purple zone. Okay, we have the yellow, the blue, and the purple. So we're going to need a test value from each zone. So I like to make a little chart to help me do this. Okay, so here's the chart. So test values. What test value do you want to use for the yellow zone? Okay, the first integer to the left of negative 1.35 is -2. Okay, so why not use -2 as a test value? 0 is in the blue zone, so let's use that for the blue zone. And the first number, the first integer to the right of 1.85 is +2. Okay, so let's use -2, 0, and +2 for our test values. Now this was unfactorable, so we're going to wind up using the entire function. I say we use our calculator though to help us. So let's go ahead and just type this function into our TI-30 XS multi-view. All right, so 2x squared minus x minus 5. Okay, so 2x squared minus x minus 5. All right, so we've typed it in. Okay, let's see, where do we want to start? Well, our first value is -2. That's what we want to find out. So we want to find out f at -2. Well, I guess I don't need to write it again because it's already right there. So we're doing f at -2, so let's start at -2. Okay, so at -2, we have 5. The value is 5. Okay, so fine. So we have a value of 5. Now the question is that less than 0? Okay, is 5 less than 0? No. 5 is not less than 0. Okay, that means negative 2 is not a solution, which means that none of these yellow values are solutions. So we'll just leave this area blank. Okay, now how about 0? Well, we've already got it in the calculator, so we can just glance at it. So at 0, we have a value of negative 5. Okay, so is negative 5 less than 0? Well, yes it is. All negative numbers are less than 0. That means 0 is a solution, which means that all of these blue values are solutions. So I will show that these values are solutions by drawing a segment in here. Okay, and finally let's test f at 2. Well, we can just look in the calculator. All right, scroll down a bit. All right, so f at 2 is 1. Okay, so we get a value of 1. And again, the question is that less than 0? Clearly, no. 1 is not less than 0. That means 2 is not a solution, which means that none of these purple values are solutions. Okay, so this is a complete graph of the solution set, and we could go ahead and write interval notation for this. Okay, in interval notation, we're going to use round parentheses because we're trying not to include the endpoints, and we'll say negative 1.35 to positive 1.85. All right, so that's it. That is the solution. And I think that was the last problem. Yeah, number 6, that was the last problem. So I hope this was helpful. I hope you guys are not just copying off of me, and I hope you're making sure that you can do these problems on your own. And I will see you on the next video, whatever that may be. Not today, though.